So we're going to be doing this lesson on solving linear inequalities. And just to specify, this is the one variable case. In the two variable case, you have to worry about lines and that sort of thing. That's going to be a separate video. So this video is just on solving linear inequalities in the one variable case. So just to remind ourselves, a linear equation looks like this. We have a variable to the first power and we have an equal sign. Linear inequalities look like this. We have ax plus b, but then instead of an equal sign, we have one of the following four symbols. We either have less than or equal to, greater than or equal to. Four different symbols. So before watching this video, you must understand how to solve linear equations. So understanding how to solve these guys is a prerequisite. If you're still confused about this, you need to go back and watch that video and do some practice problems first. Okay, we're going to assume knowledge of that to do the linear inequalities. Okay, so to solve a linear inequality, means to isolate the variable. In other words, you're going to get something that looks like this. One of those four symbols and then a number, a. Okay? Usually we have the variable on the left, and I want you guys to get used to putting it on the left, and I'll explain why in a little bit. This is going to make drawing the picture a lot easier and more systematic when you do it. Okay, so since we're just trying to isolate the variable, we hope that all the steps from solving linear equations work, and they do. So to solve a linear inequality, do all the same steps as if it were a linear equation. There is one catch. So the one thing you need to notice when multiplying or dividing both sides of an inequality by a negative number you must reverse the direction of the inequality symbol. Reverse just means if you start with less than, it becomes greater than. Less than or equal to becomes greater than or equal to. Greater than becomes less than. And less than or equal to becomes greater than or equal to. Less than or equal to. Okay, so these are the four different swaps that can occur. This is only when you multiply or divide the inequality by a negative number. Not adding or subtracting, just multiplying and dividing. Okay. Now, before we talk about how to actually solve these equations or do some examples, I want us to talk about writing our answers in interval notation and also graphing our solutions. Okay? So first let me talk about interval notation. Interval notation is a notation in math that's really important. You're going to learn it, use it a lot in intermediate algebra as well, and in every future math class. Interval notation is when you have a set of numbers that lie in a row on the number line. That's what we call an interval. You always write it as a starting number, comma, ending number. Okay, starting number, comma, ending number. Also, you can put a bracket or a parenthesis on either side. Okay, a bracket means that you include the endpoint, and a parenthesis means you do not include the endpoint. Okay. Same thing on the other side. Bracket means you include the endpoint. Parentheses means you do not include the endpoint. Okay. One thing that we have to mention, so note, infinity is never included. So actually, let me write plus or minus. So either positive or negative infinity is never included. In other words, always use parentheses with plus or minus infinity. Okay? What about graphing? Well, I'll remind you guys of how to graph in case you've never seen this before. So this is when you have a variable on the left. Okay? If you have greater than or equal to, this means that you shade to the right. And if you have a less than or equal to, this means that you shade to the left. Also, if you have greater than or less than, it means you do not include the endpoints. So we use an open circle. But if you have less than or equal to or greater than or equal to, we use a closed circle. Okay? So let's put all of this together and let's do some examples. We're not going to actually solve some inequalities here. What I'm going to practice doing is actually just writing down an inequality and then putting it in interval notation and then graphing it. Okay? Actually, I'll do it in the reverse order. So we're going to do the inequality, then we're going to do the graph, and then we're going to do the interval notation. We'll do all 4 cases so that you guys can get accustomed to how you write these down. The first one is going to be, what if you have x is greater than 1? Well, to do a graph, you always draw a number line, and you always put your number, your key number there in the middle. Now this says x is greater than 1. Well, first we put a circle around 1, and we're going to shade to the right, because it says when you have greater than or equal to, you always shade to the right. Now, do we shade in the circle or do we not? Well, look up here. Because it's greater than, it means it does not include 1. And so that means I don't actually shade in the 1. So that's it. That would be the graph. What about the interval notation? Well, what number does it start at? So it starts at 1. So it's going to be 1, comma, something. Where does it end at? Well, we look at how far to the right it goes. Notice it goes to the right forever. So if it goes to the right forever, you can think of infinity as being here. Negative infinity as being here. So this looks like it's starting at 1 and it goes until infinity. Now, we do not include 1 because it's not greater than or equal to. We don't include 1, and remember, infinity is never included. So we put both as parentheses. All right, that was x is greater than 1. Let's try another example. X is greater than or equal to 1. So let's draw our number line. There's 1. Now, it's greater than, so we still shade to the right. However, we do include 1 this time because it's greater than or equal to. Okay. What about the interval notation? So notice that in this case, since 1 is included, I'm going to use the bracket instead of the parenthesis. So I put bracket 1, and it still goes to infinity, but remember, we never include infinity. Infinity is not actually a number, so it just means go to the right forever. Okay, let's do another one. How about x is less than 1? When we have x is less than 1, we're going to draw our real number line. There's 1. Now in this case, because it's less than, we shade to the left. Okay. Now, do we shade in the 1 or do we not? It turns out we do not. Because it's less than, that means we don't actually include 1. So we just leave it as it is. Now let's be careful here. In this case, we're actually starting at negative infinity, because that's the left of 1. And then we go to the right until 1. So the way we would write this down in interval notation is from negative infinity until 1. We don't include either 1 in this case. Last problem. X is less than or equal to 1. Okay, for the graph, we still put our real number line, and we have 1 right here. I still shade to the left because it's still less than. But because it includes the equal as well, we shade in the 1. So actually, we're going from negative infinity until 1 again. We're not including negative infinity because we never include infinity, but we are including 1. So that's how we put our answer. So these are the 4 cases. This is how you write your answer down. To the left, so this is the second part of the solving linear inequalities video. Okay, so this is solving linear inequalities, part 2. And so we're actually going to be doing examples now. This is going to be a short video that's made to accompany the other video. So, for the following inequalities, you're going to first solve the inequality. The second step is to graph the solution set. And the third step is to write the solution set in interval notation. Okay, so these are the three things we are going for when doing the following examples. Okay, so let's do a couple of these. I only want to do a few to illustrate the point. So number 1, c minus 6 is less than or equal to negative 3. We're going to start really basic here. So, first thing we want to do is we want to solve by isolating the variable. So I can add 6 to both sides. I end up with c is less than or equal to, and I added 6, so I get 3. That's my solution. Then it also says graph the solution set, so I create my line. There's 3. Because it's less than or equal to, I shade to the left. And because it's equal as well, I do shade in the 3. I include that in. So there's my graph. Finally, to write the solution in interval notation, it goes to the left till negative infinity, and to the right, it goes until 3. Remember, you never included negative infinity, and we are including 3 this time. So there's my solution. Alright, so we've got our solution right here. Here we've got our graph. And here we've got interval notation. Okay, let's do another example. How about negative 4y is greater than negative 16? Negative 4y is greater than negative 16. First thing I'm going to do is isolate the y. So I'm going to divide both sides by negative 4. If I do that, I have the y here, and I have the 4 here. But be careful, because I divided by a negative. Recall, that means that we have to reverse the inequality sign, so the greater than becomes less than. So y is less than 4. How about our graph? Here's our number line. Here's 4. We shade to the left because it is a less than. And we do not include 4 because, again, it is a less than. So that's how we leave our answer. Finally, solution set in interval notation. Interval notation, we have to write down where it's starting, where it's ending. In this problem, again, we're starting on the left one. Okay, that means that if this is negative infinity, we're beginning at negative infinity and we're going until 4. Not including the negative infinity and not including the 4. So this is my solution. We're going to do 1 or 2 more actually. These are going to be tougher, multi-step ones. Let's do the following. 5 times 2 minus 3h plus 9h is less than or equal to 2 times h plus 1. Let's remember the steps from solving linear equations. First thing we do is we distribute the parentheses use the distributive property in order to eliminate the parentheses. So I can distribute this 5 here. I get 10 minus 15h plus 9h less than or equal to, and if I distribute the 2 here, I end up with 2h plus 2. Now there's no fraction, so I can skip that step. So I combine like terms on both sides. Negative 15h plus 9h is negative 6h plus 10 is less than or equal to 2h plus 2. Now, because I have variables on both sides, I have to move all the variables to the left by subtracting. I get negative 8h plus 10 is less than or equal to 2. And I can move the 10 over as well by subtracting. I get negative 8h is less than or equal to negative 8. Now, to isolate the h, I divide both sides by negative 8. I end up with h is greater than or equal to 1. Remember, we have to reverse that inequality sign. Okay, so this is our solution. For our graph, here's our real number line. Here's the number 1. It says greater than, so that means I go to the right. Also, since it's a greater than or equal to, that means that I have to include the 1. Finally, we have interval notation. This time we're starting at 1 and we're going to the right forever. So in fact, it's from 1 to infinity. We are including 1, but we're not, of course, including infinity. There you have it. We have solution, we have the graph, and we have the interval notation. Let's do our last example. This one's going to be tricky because we're going to have fractions in this one. So this is number 4. We're going to have 8/3 times 2k plus 1 is greater than 1/6 k plus 8/3. If you remember from our section, Solving Linear Equations, first thing we're going to do is to eliminate the parentheses by using the distributive property. So I get 8/3, let's go ahead and put this over 1. It's 8/3 times 2k plus 8/3 times 1 is greater than 1/6 k plus 8/3. Or, if I distribute here, or actually multiply this out, I end up with 16k over 3 plus 8/3 is greater than 1/6 k plus 8/3. Now I'm going to multiply by the LCD to clear out the denominators. The LCD is 6. So I'm going to multiply the entire thing by 6. Let me go ahead and write it out like this. 6 times 16k over 3 plus 6 times 8/3 is greater than 6 times 1/6 k plus 6 times 8/3. Cancel in each one. Here the 3 and the 6 reduce. I have 2 left. And 2 times 16k is 32k. Plus, here the 3 and the 6 reduce. 2 times 8 is 16. Is greater than. Here the 6's cancel. I get a k. Here the 3 and the 6 reduce. I get 2 times 8 is 16. So I get this. Now I use my adding and subtracting to move all the variables to the left. I end up with 31k plus 16 is greater than 16. Subtract the 16 from both sides. I end up with 31k is greater than 0. Divide both sides by 31. I get k is greater than 0. So this is my solution. What about the graph? Well, here's 0, and it's greater than, so I shade to the right, and it does not include 0. does not include 0 because it's just a greater than. So that's my whole graph. Finally, interval notation. This time we're starting at 0 and we're going until infinity, right? Because we go to the right forever. We don't include either one because 0 is not shaded in. So this is my solution set. That's it for the two-part video on solving linear inequalities. I hope it was useful, and I'll see you guys next time.